Well, welcome back. And here we are. We are starting on, I think I called it Parsing Floats for Fun and Profit. Um, if you can dodge an int, you can dodge a float. I don't know. I just tried to come up with a good name. What we're doing is we are adding the ability to process floating point values to our language, Tang, that we have been building. Again, it is a custom programming language built in C++, and we've been building it from the ground up. Having said that, let's go ahead and jump in. There's actually, it's not too difficult. We've laid a lot of the groundwork already, but we have to touch this project in multiple places in order for this to work. So let's get started. The first place we're going to go is Bison and Flex. And let's see. Let's just open Flex. Yeah. Our scanner, and also open Bison, our parser. And again, there's all sorts of documentation here. But what we're going to look at is our tokens. And this one here, You say, Corey, you're already stumped? Yes, I am. What I'm wanting to do is add a new token here. Okay? Simple enough. But what type do we need to do it as? And you say, why didn't you figure this out before you started recording? Well, because I wasn't thinking about it. For right now, until I can come up with a better reason, I'm going to use a double. And we're going to call this a float. And the user-friendly name is float. And we don't need to do anything with the precedence rules yet. And we can go down here and say, how do we recognize a float? And the first one is, well, we have an expression here that could be an integer, and we're going to add this as an OR. So the pipe will work for that float. And since we said in the token that it is a double, that means $1 is a double, and @1 is the location. And so what we need to do is $, that means the return. In other words, what expression will be, the value it will receive is the $, is going to be a new Tang AST node float with $1 @1. And that's it for this part. Now we've created this. That is, we've declared that there's this float. There's this type of thing, float. If I were to say make, well, just make tests or make whatever. If I were to try to compile it, it would create a method called float, right? I mean, in the Bison, in the parser, that Flex needs to use. Okay, so now we have to go over to Flex and tell it when we see a pattern that looks like a floating point number, then we want to make this float thing. And the float will call this AST node float. That doesn't exist yet, so we'll have to add that. So first, let's go to Flex, and we need to say, let's see, here we go. So we need to come up with a pattern. You know what? I'm just going to copy this. And the question is, I'll put it second, make I'm on caps lock, that's why. Make a float, number, location, that's all the same. And that's what I was saying. By saying in the other file, the token float, it will now exist as part of Tang parser. And this is going to be a double. And then instead of stir to LL, I don't remember what we can use there. Oh. To LD. You know what? I'm going to use a long double. I have decided. Long double. That means I need to go back to the other and that token needs to become a long double. And that should be a 64-bit double. I hope. Either way, we'll see. We'll see what happens. Actually, we're going to have to solve this pretty soon. I just realized that. All right, well, here goes. Go back to B1, and we need to decide what it looks like. What does a floating point number look like? It can have a minus. It can have any number of values. Now, this is an interesting thing. Do you want, and I'll do it on the right-hand side. If you had the number 0, that's obviously a 0. If you had 0.5, is that legitimate? I mean, if you have 0.5, that's obviously a float, but should you require the 0? What if somebody did 0.5? Would that be a problem? In some systems, having a 0 in front of something indicates it's an octal number, a base 8 number. So or for that matter, if you have a 5 point, but you can't just say the part at the beginning is optional, because, okay, so 5 point makes sense that it would be specifying a floating point number. But, so that means the last part is optional if the first part is there, and then if the first part isn't there, then it should require something that would be a floating point 0, or 0 point would be a floating point 0, either one. But just a period by itself, in other words, they're not both optional. It's that it's got to either have one or the other. And yeah, so let's figure out how to write this regular expression. I'm going to leave the minus with a question mark, because that means it's optional. And I think I like to treat this as two potential possibilities. And you do it one way or the other. So the first would be one or more numbers. That's what this means. Followed by a period. But I can't just put a period because that means a literal value. So it has to be a backslash period. And that means a literal period. We're escaping it. Followed by any number of 0 through 9. Right? So this would be we could have the 5 point, and it would be a floating point 5. We could have 0, 0, 0, whatever. Is that good or bad? We can maybe need to tweak this later. Alternatively, start off, nope, that's not what I meant to do. Start off with a period followed by 0 through 9 plus, and that means one or more. That should work. Okay. Now we have to test this, right? And we'll do that in just a minute. But the last thing we need is, we said when we see this, create an AST node float. That doesn't exist yet. So yeah. So we need to edit the include for AST node, AST node integer, and I am going to copy all of this. There we go. And instead of that, we're going to say float literal by the long double. And this is float float the number, the location, that's fine. And what is val? It is the float long double, dump, compile, make copy. Okay. This long double thing is making me nervous. I'll say why in just a moment. So now we're going to do source AST, and we've got st node integer. We're going to again copy and paste those, and now compile, make copy. Float through this, it's going to be float. There we go. The caps lock gets turned on and it does all sorts of different commands, and I don't know all those other commands. I don't know what this is going to be yet, but we'll look at that. I don't think it's right. It may not even compile. But we'll see. Oh, and this needs to be float. And we're going to make a float of this val. Okay. I'm kind of curious if this is going to compile yet. Okay. Oh, the opcode doesn't exist yet. And where is that? That is Control E, include opcode. Float. All right, that's what I was afraid of. It is of size 16. So what I'm thinking, here's the problem. Right now, the way our opcodes work is that they are all, 64-bit. And the long double is a 128-bit. Do we really need 128 bits? I don't know. I don't think so. But maybe. But more importantly, the problem is, if I say uint 32t, that's going to be a 32-bit integer. If I want to say uint 64t, that's a 64-bit integer. But there is no equivalent for that for floats. There is no float 16t. And depending on what system you compile this on, this could be a 128 bits. Wait, is that right? It's 16 bytes, 16 times 8. Yeah, 128 bits. Or it could be only 64 bits, so it'd be the same size. So whatever we do, we have to convert it. So let's go back to our ast.cpp, because where we're getting into trouble is on the compile. And this is on the float compile. Now, why would we do a bitcast? First of all, our opcodes are all uint 64Ts. Okay? They all are. Period. That's what they are. But the this arrow val could be, so it may need to take up two of them or only one. And it really depends on how big it is. So but this isn't quite right. So the question is, how do we do this when uint64t is not... Oh. So I'm going to bitcast this as a 128T. The reason I'm undoing that is because I want a copy of it down there. Okay. Is there a 128T? There is not. You know what? There's an easier way. There is an easier way. Well, I think it's easier. I tell you what. We're going to, for the moment, just switch it to a double, and then I will work on a solution. What I think we're going to do is have to conditionally declare the type that we use by bison and flex. So yeah, we'll have to do that. So let's go back to the AST. Control B3. And just, it'll be a double val. And now it doesn't like it because we're going actually, will it do that without any? Stir to LD. I know it exists. I'm probably just missing a... It's in C standard lib. Did I not include that? That's going to be in 1. I'm including C standard lib. Oh, that's not the problem. Now I'm going to double check my notes. Well, watch it be this. Oh, okay. All right, so there we are. So far, we've got it. It's not giving us any complaints. So we are using a long double in the lexer and parser, but it narrows to, intentionally so, narrows to a just a plain double for now. And what I'll probably do is I will go through and just do some pound defines, or you know, if the size of, and use a, yeah, we'll do something that defines the type for a floating point so that it's always the same size. That's the goal. Okay. Well, let's actually make it parse something, shall we? What else did we say? Let's We want a point to, and this one can be, what do we want this to be? How about a 0 dot? One more. Okay. It in case you're wondering what's happening, it's stuck. Here, let me show you. Well, I'll open another window. HTOP. And we've got one processor pegged out at 100%. And that is this build thing. Okay. Let's kill that. And we'll talk about why. Why? Because buffers, we've got, we don't have one for programs. So let's do that. So we're going to, our source/program. And we added an opcode. Okay, so let's get to dump. And we're going to y. Okay, and I like to keep these in the same order as they were declared. Float. And float. And now this needs to be a bitcast to a double. That's the first thing, but that's not the most important one. This one, it didn't know what to do when it got to the opcode because we didn't have anything for the break. We should have something that, you know, exits with a an unknown opcode as a runtime error, and we'll get that. So float, garbage collected, computed expression. Didn't mean to do that. Computed expression. Nope, float. And we want this as a bitcast of a double now let's see what it doesn't like about that. Bitcast is not declared because there should be an underscore. Where did I do that? I may not have. Bitcast is not declared. Now for that, what library is bitcast? Maybe bit. It is indeed bit. Okay. All right. So it doesn't know how to garbage collected. Computed expression float. Oh, we haven't done our computed expressions yet. And we haven't opened computed expressions. That's why. Okay. We've got our computed expression integer. Represent float that is the result of a computation, and this is going to be computed expression float. This is a double. Virtual bool is equal. And we are going to even make one for a float. That's fine. Okay. And we're even going to copy that and okay. And now we need to create this. First, we'll look at, we did an is equal for integer, and we're going to do one for a float. And we're going to compare this, because we're in an integer, we will make this a double and just see if they're the same. But now that I've done yank, and I don't know how to do a mass change to float. There's obviously some way of doing it, but I don't know. This is going to be a double val. Okay. Float to string, that should work. Computed expression float, and we're going to make a computed expression. And we're comparing it to an int. So we're going to return, convert that integer into a float. That's fine. And then so is equal float const marked override, but it does not override. That's because we need the default one, and that's going to be is equal with a, not a float, a double. And now be, I don't even know what number we're up to, 8. By the way, that's why you use override, because as you can see here, it's saying, hey, it's marked override, but it's not overriding anything. It told me where my mistake was, in essence. So here we are, y7. All right, so now, oh, because it's float and it should be a double. And I probably made the same mistake down here. And now, go up to the first error. With no type. Evidently, I don't know how to type the word float. It says we passed all of our tests. Let's break some intentionally. Which one is the test? Number 6. That should fail. Yep, and notice it says it prints out 0.000000. It should be 0.1. That's good. Okay. Let's do... I want to check 3.0 versus a 3. Likewise, up here, I want to check this against a float. And I want this to be not equals. $42.5, why not? And same thing down here. We really just kind of want to say it, whoops. It does not equal, and what are we going to check against? I want to make sure that if I have a 3.5, it does not equal a 3. Everything passed. All right, so yeah. Now this is, I'm going to, instead of saying integer, we're going to say declare integer and declare float. That's better. And I think this puts us at the end of what we need to get done today. And here, let's a lot of changes. So what all did we do? We added a token to Bison. We added, and added it to our grammar. We added, in Flex, we told what pattern represented a float. Then we created an AST node type to hold the float. And we had to, then in the computed expressions, we had to create a computed expression that would hold the float. We're using doubles for these, but I'm just calling float as a generic floating point object. We wrote an opcode for float. And for our AST node, we wrote a dump procedure, the compile procedure that does some bit casting, and yeah, it makes a copy. Okay, that's fine. We have some equality checks for the computed expression so that we can use it with Google Test. And last but not least, we can execute them. We wrote some tests to cover all of that, and it is working. Normally I would add them individually, but I'm just going to say git commit-am, and we add support for floating point numbers as expressions. All right, now 147 insertions. That was a lot more. In fact, make clock. Yep, it's starting to climb up there. And let's do our make docs-pdf and see. I think it's the docs. Okay, and there we go. Nothing new, except if you start looking into AST. You'll see now there's an AST node float. And of course, it has all of its documentation. It's working. Yeah. So our list is starting to get larger. It will get significantly larger. That's for sure. And all right, so git add docs. Just to make sure we're not committing anything we're not expecting. I always have to ask, what episode are we on? Episode 12. So for episode 12. There we go. All right, it is there, and now we have, we can recognize floats as well as integers, and our system doesn't confuse them. So now that we've got this, what are our other basic types? We're not gonna do them yet. We're gonna make it add these two together and give us something. Add together an integer and an integer, you should get an integer. Add together an integer and a float, you should get a float. Add together a float and a float, you should get a float. Things like that. So that's our next goal, is that we want to start with this. Start adding these together, or start having an expression that is more than just a single value. And hey, that's where our virtual machine starts coming into some interesting stuff. So once again, I want to thank you for joining me here, and we're making progress. And as always, hey, have a great day.